My name's Chuck Canisto. I'm the Southeast Regional Manager at Cogsdill, and I'm going to talk about Shefcut reaming and fine boring tools. Now, we call them reaming and fine boring tools, but actually they're very different from typical reamers and boring tools. The difference is we have a single blade that is both replaceable and micro-adjustable, and then we have guide pads to steady the cut of that blade to give you a very precise size. We have Shefcut tools in a standard configuration where we have many different sizes, we have different work lengths, we have different blade leads, and we have different pad options. We also have special tools that are made specifically for your application, and we have many tools that can do multiple operations, can also eliminate many secondary operations like grinding, honing, and multiple reaming and boring. All right, Shefcut tools, unlike conventional fluted reamers with many fixed cutting edges that try to cut and guide at the same time, the guide pads are ground right at the low end of the tolerance, or just below. They offset the cutting force of the blade to ensure stability and alignment and produce extremely straight and round bores. This tool can actually produce tolerances down to tenths or microns and give you extremely smooth finishes. In comparison to single point boring, the problem of deflection is totally eliminated. By the support of the pads, the length to diameter ratio is no problem. The standard cutting head design consists of the blade, the clamp, the front and rear adjusting screws, and the guide pads. The pad is positioned lengthwise by a stop pin back here to ensure that we have the right blade advancement. Adjustment screws make sure the blade cut diameter is positioned diametrically very close to the pad diameter. Because blade and pad diameters are so close, it cuts exactly to your required size with an unparalleled round and straight bore. In order to function properly, the blade must be set. The front cutting edge must be tenths or microns above the pad diameter and then back tapered down so that it's slightly below the pad diameter on the back side. The blades can be set a number of ways, but the quickest and easiest way is to use a Shefcut setting fixture. They can also be set in the machine by using a tenth indicator and zeroing off the pads and then setting the blade slightly higher in the machine. You can also use pressure mics or regular micrometers, but you have a problem of possibly chipping the blade because the blade is extremely sharp. You can somewhat duplicate a Cogsdill setting fixture by using a set of bench centers and a tenth indicator on a stand. The blades are set at the factory, but due to shipping or possible inadvertent turning of the adjustment screws, they should always be checked. Okay, to check the tool, we want to put the tools between centers. Make sure everything is locked down good. Now we'll pick up on one of the pads with the transducers, and all we need to do is just zero off of those pads. So we just turn the knob here, and right now we're reading in the fine setting, which is 0 to 10 right here is 1,000. So each one of those increments is a tenth. We have these setting gauges in both inches and metric. So we're looking at the first pad now. Make sure that's zeroed out. Make sure we have consistency between all the pads. And typically, as long as they're within 2/10, that's more than good enough to cut a very good size. So we come to the second pad here. We can see we're well within that. And the third pad, now we'll swing it around to the blade, and you can see on the okay, this gauge is showing the front cut diameter of the tool, and you can see we're about 3/10 above the pads, and we're about 3/10 below in the back. So the back taper of the blade is about 6/10 altogether. So this tool is ready to go. Okay, after the tool's been run and it's time to change the blade, the first thing you want to do is just slightly back off the adjustment screws. Now you loosen up your clamp, and you can take your blade out, and in this case I'm going to flip it over 180 degrees where we have the other edge. You want to make sure that we don't have any chips or foreign material in that slot, because it's very important that we have the right amount of blade advancement. So we'll just put the blade back in the slot, make sure it's up against the blade stop to ensure that we have the right blade advancement, and we'll just clamp the blade back in. Now we'll put the tool back into the fixture. Lock it down. Once again, check your pads, zero off the pads. Make sure we have that same consistency in the pads. Now when we come around to the blade, you'll see that we just barely are picking up a reading on there. So we see our back taper is just slightly below our pad diameter, and the front is about 0.8 below. So now when we adjust this front adjustment screw, that works out perfectly. The back one will go down a little bit. Make sure you're on your high point. Get your cut diameter anywhere from about 2 to 4/10 is fine for most applications. You don't have to have it exactly. Remember, we're talking in tenths or microns. And anywhere from about 3 to 7/10 below on the back taper will work for most applications. Now, the closer the blade is to the pads, the rounder and the straighter your hole is going to be, but you're also going to have less amount of wear on the blade, and you're also going to be less tolerant of misalignment in the operation. This tool's now ready to go again. Our Shefcut catalog has technical information in it. It's got tool specifications. It's got all of the different standard tools that we offer. And you can find all of that in our catalog, but most importantly in our catalog, in the back we have a data sheet. We'd like you to fill that out so that we have all the information we need in order to get the exact design that you need. If you need more information, you can go to our website, www.cogsdill.com, or contact your local Cogsdill regional manager.